Hello everyone. This is Görkem Güngör from Acıbadem Maslak Hospital, Istanbul, Turkey, and I am the lead medical physicist of our group. And today my topic is about experience with our new project Elekta Harmony. This is my conflict of interest disclosure. So let me start to tell about some brief information who we are. First of all, let me explain that we are the biggest private hospital group in Turkey, and in total we have 21 hospitals located at 4 countries. We have 14 outpatient clinics, and in total we have 11 radiation oncology departments. Acıbadem Maslak Hospital and Acıbadem Altunizade hospitals are our main flagships of radiation oncology departments. In this regard, we have 20 linear accelerators. Additionally, we have one gamma knife, we have one cyber knife, one tomotherapy, and one 0.35 Tesla MR-guided radiotherapy unit. And additionally, we have four high-dose rate brachytherapy systems. As you see that we are capable to treat every kinds of radiation oncology techniques such as SRS, SBRT, VMAT, IMRT. It doesn't make any big trouble for us. Hence, in order to control this kind of huge empire, we have 21 radiation oncologists and 22 medical physicists serve for radiation oncology departments. Additionally, we have 48 RTTs and we have finally 9 dosimetrists. So let me give detailed information about our project, how it started and how ended up. So we first established our Elekta Harmony project in our Acıbadem Bursa hospital. Acıbadem Bursa hospital is very important for us. You know why? It is because the first Acıbadem hospital in Anatolian part of Turkey and first premium LINAC installation was successfully achieved in Turkey in 2008, and first IGRT based IMRT treatment was achieved in the group and in Turkey as well, and first CBCT guided SPRT treatment was achieved there. First Elekta Harmony installation in Turkey and in the globe was achieved there. And finally, it is the first project for a radiation oncology department at Acıbadem Healthcare. So, Acıbadem Bursa is our laboratory, and if something is successfully achieved, it means that this result will be used for future for mutual benefits in our group. So let me show you where is Turkey, where is Bursa Acıbadem Hospital. So this is our hospital. Previously we had two other vendors LINACs, and we take them off and installed one Elekta Harmony, and nowadays we had finished the Elekta Versa HD LINAC in our hospitals. In the first steps of our project, of course, in the round table and for the decision makers, there are some expectations and demands for different part of the workers in the hospitals. For instance, the decision makers, physicians, and the medical physicists and the RTTs, expectations and the demands are totally different. So we made a round table and we classified the expectations and we try to find what's the best project and what's the best LINAC for us. So it is very important. For example, for decision makers, the machine is supposed to be cost effective, feasible investment, suitable for financial options, and it has to be a capability of treat more than 50 patients per day, and the expected uptime should be over 99%. Extended service agreements, fast maintenance supply were important for them. And for physicians part, they want to treat hypofractionated every kinds of treatment fields, conventional, unconventional treatments. They want powerful IGRT options, and they want to use every kind of IGRT such as triggered CineMod treatments, and they want to be part of the research consortiums. For medical physicists, their demands were much more technical centered. Faster treatments, high dose rates, triple F options, very consistent MLC movement. They want to treat conventional dynamic conformal arc, IMRT, VMAT treatments, and they wanted Monte Carlo calculations, for instance. Portal dosimetry and twin LINACs, energy matching, beam matching, LINAC matching was very important for them. For RTTs, accurate imaging systems, high quality MV, KV, and CBCT imaging, fast IGRT, fast setup were very important for them. At that point, our journey were started. First official contract, and then choosing the dosimetric equipments, choosing the peripheral devices, and choosing the fixation equipments. After that, bunker preparation has started, and we made the calculation of 6 MV triple F shielding calculation, and we pointed out the isocenter location. Next, installation phase 1 and phase 2 started. The Harmony came to our country, and the installation has started. The beam line, the vacuum on, modulator on, peripheral systems on, TPS and TDS installations, and everything is started after installation phase 1 and phase 2. Immediately, we jumped to the beam data collection with Elekta Harmony system. We are very lucky that we have AGL measurement option, and with AGL measurement option we finished Monte Carlo measurements in a very short of time. I will explain detailed later with later slides. Then, after finishing beam data collection, our staff got some training about Monaco, Mosaic, Aqua, and Harmony. Finally, at the end of these steps, we had go live, and with go live, we treated around 10 patients, and it was very successfully. So this is briefly our journey. All right, before go live, we had a design in our minds. We had an ecosystem design in our minds. In this ecosystem, in our one hand, we would have Elekta Versa, and on the other hand, we would have Elekta Harmony. So with these two LINACs, we must treat every kinds of located lesions, either complex or easy. But when a patient comes to our department, we shouldn't reject them, and we must treat them. At that point, surface-guided radiotherapy, IntelliBeam, XVI, EpiBeam, EpiGray, machine QA, online machine QA, and QA-related network systems are very important for our ecosystem. So we distribute these options to both of our LINACs and both of our systems. Our ecosystem was powered with Prono, Mosaic, and Monaco as well. At that point, I like Prono very much because you collect the cumulative DVH, you collect every kind of information in your department, and it is a network-related system. It can be a cloud-based system, so you can see everything in your department. So that's why it's very important for us. And for Aqua machine QA system is also very powerful in our department as well. So you can collect your machine QA data, either Elekta system or any other vendor, and so you can analyze the trend of the data and what's going on for the department's problems or the solutions as well. At that point, this ring show us our ecosystem in Bursa Acıbadem healthcare. But the ecosystem is not only the unique key factor for the success for this project. Triage for the treatments are also very important, as I mentioned earlier. So at that point, we triaged our conventional SRS and SBRT cases into three parts: we classified as easy, difficult, and very difficult. So brain tumors, head and neck tumors, breast, lung, abdominal, pelvic irradiations, vertebra or bone metastases, multiple or single oligometastatic cases are classified as easy. Liver, hepatocellular carcinomas, prostate, peripheral lung, central lung, SBRT is classified as difficult. Adrenal and multiple brain mets as well. And pancreas, biliary tract tumors, liver mets, ultracentral lung SBRTs, and the kidney tumors are classified are very difficult. Point. These easy, difficult, and very difficult cases are distributed to Harmony, Harmony and Versa alone. As you see that our bunker is very small, so we took our old LINAC off from the bunker and we put our Harmony in our small bunker. Harmony fits every kind of bunker, either small or big bunker. It doesn't make any sense. But if you have another vendor system that the ISO centers can be different and you have to calculate the radiation protection calculation with respect to new ISO center, but it has a single energy and it didn't create any problem for us. So this is the Harmony installation. These photographs are taken at the pre-installation phase. As you see that it is very small, it is very compact, and it fits every kinds of bunker, as I mentioned. And after we finish the installation, so this is the post-installation results. So yeah, it's very beautiful. It suits to the bunkers very well. The couch, the gantry consistency, the collimator consistency. So we are very happy to have this kind of LINAC for our new project. So I explained who we are and what was the project, and at the end of these steps we made real-time treatments and we made go lives, as you understand. So at that point I would like to give you clinical evaluation examples and results and give some anecdotal solutions for our clinical evaluations. First of all, I would like to give you our new patients per month results. So between 21 May and 22 August our patients started from 8 to 77 per month. As you see that there is a huge amount of patient load and per month, and we were happy to overcome this patient load successfully by treating Harmony. So this is our patient load per day, and red represents the 5-day average of our patients numbers. As you see that we started with single patients, and during the go live we treated 10 patients, and after 3 months later we jumped to the 50 patients per day, and then we jumped to the 90 patients per day. These are extraordinary numbers, I know, but with this machine you are able to treat this kind of numbers per day and per machine. Nowadays our numbers are flat and we are treating around 75 patients per day per LINAC, and the system is very stable and very consistent in terms of without giving any disruptions and any unintended breakdowns. So this is our treatment indications. 50% of our treatment indications related with thorax locations, and the rest is head and neck, abdominal, and pelvis. Mostly we treat breast cancer, lung cancer, prostate, rectum, pancreas, GBM, and stomach. First treatment time was a big question mark for us as well. We didn't know that how many minutes do we spend for a treatment slot with our new machine. At that point, I created workflow steps for our new machine. So patient setup, mod up, IGRT analysis, beam on time, and patient bunker out is set as a workflow steps of our machine, and the summation of these represents a total treatment time. If we subtract total treatment time from patient bunker out, then we obtain net total treatment time. And for conventional fractionated treatments, our net total treatment time is approximately 8 minutes. In 8 minutes, you finish at any patient's treatment in the bunker. So At that point, I can confess that this time is very short, and for huge number of patients, it was very vital and very important for us to achieve a successful and high quality treatment with our machine. And with 8 minutes, we are very happy to treat our patients. So let me give you some examples, some anecdotal examples with our new machines. Of course, with elder machines, we had great experience with every kind of treatment techniques. But with new LINAC, you feel some scary, all right? So you couldn't feel yourself comfortable and flexible with new cases. In the first days of our go live, we were expecting easy cases, but unfortunately, we got some extraordinary cases, such a pediatric craniospinal case. So at that point, we choose an IMRT instead of VMAT or conventional treatment. We gave 180 centigrade with 20 fractions, in total 36 gray. Because of arm violations, we made the arms down, and we use 14 fields with brain and with the whole vertebra, and we made KV-KV matching for these pediatric case. So this is the DVH results of this pediatric craniospinal case. As you see that the dose gradient is very good, dose coverage is very good, and the critical structures, dose receiving, are not violating our department rule. And the number second was an adult craniospinal case. At that point, conversely, instead of we are using IMRT case as we did for the pediatric case, in that case we performed to use VMAT. So we performed 3 isocentric VMAT option for these gentlemen, and we prescribed 180 centigrade with 20 fractions, in total 33 gray. As I mentioned, we made a 3 single arc with partial arcs. It has an arm problem, as you see, and we didn't use arcs penetrating from the arm, and we made a KV-KV matching. So this is the third example. It is a head and neck case, and we prescribed 54, 60, and 70 grays in 33 fractions at the same time with SIB technique. We performed a VMAT treatment with single arc with 4 fields. We performed KV-KV matching and CVCP matching for successful treatments. As you see that those distributions and the DVH of the patients are very acceptable and satisfactory. So finally, let me give you the technical evaluation of the machine. How this system can treat patients very successfully and give you an very elegant dose distribution. First of all, it starts with beam data collection. We perform beam data collection with our PTW equipments. We use microdiamond for relative measurements. We use Farmer ionization chamber for absolute measurements, and we use MP3 system. For end-to-end tests, we use PTW Octavius system, and we use PTW Unidos for electrometer measurements. Before AGL measurements, I have some. I was curious about the EGL, and it doesn't feel relaxed with EGL measurements. So, but after I got the results with EGL, I must say that EGL saves medical physicists' life during the acceptance and the commissioning measurements. This is the EGL measurement data. You have to collect PDD, OCR output, and wedge measurements with these 4 fields and with these 4 depths. After you collect this data, you send it to the Elekta medical physicist, and they check your data, and if they approve your data, you are easily able to upload your data to your Monaco, and you start to make some plans, some measurements with your system. In our department, we finish our EGL measurements in a single day. It was unbelievable. We finish our measurements in a single day, and we send the data Then the checking of the collected data was performed, and officially we finished our AGL measurements and commissioning and acceptance test of our TPS in 3 days. So we gained tons of time for extra end-to-end measurements and for extra tests. So I'm very happy to use EGL measurements. So this is the validation of Monte Carlo system with EGL. These are the comparison between measured data and the golden data, and these are the gamma pass for PDs. So these are the gamma pass rate for profiles. As you see that you use 3 millimeter DT and 3%, those differences for gamma analysis. So this is the technical specifications of Harmony. It has an agility MLC, which is, I think, the #1 in the world. You are able to use dynamic conformal arc, IMRT, VMAT. It has 6X and 6FFF energy options. For another Harmony option, you are able to get 10 MV as well, but in our departments, we use 6 and 6FFF. It has fast single isocenter, and the dose rate is 1400 mu per minute for dose rate. So this is our mechanical isocenter limits. As you see that our gantry angle deviations and the cross hair deviations are less than 1 millimeter. So the system's isocenter verification and the reproducibility is very high. And this is the imaging and the beam isocenter coincidence. As you see that it is less than 0.5 millimeter. And so in total, our mechanical consistency is less than 1 millimeter, and our radiation and imaging isocenter is less than 0.5 millimeter. So it means that you hit the target, you hit your isocenter without any problem. As a conclusion, this is the first Elekta Harmony installed in Turkey and in globe. We are treating approximately 70-75 patients per day without any unintended disruptions or breakdowns. Our average treatment time slot is around, as I said earlier, 8 minutes, and so we are happy to treat our patients very fast and with high quality. So we are very happy with our new system. All right, this is my last slide. Thank you very much for joining me. It was an honor for me to be part of your congress. I hope everything goes very well. Thank you very much.
Estamos aqui para cuidar. Estamos aqui para tratar. Na verdade, estamos aqui para você nos conhecer melhor. Nós somos a Elekta. A Elekta foi fundada em 1972 em Estocolmo, na Suécia, por Lars Leksell. Ele foi o inventor da radiocirurgia e desenvolveu a plataforma radiocirúrgica avançada que leva seu nome, Leksell Gamma Knife. A Elekta é líder em tecnologias de radiação de precisão para a medicina, desenvolvendo soluções de tratamento avançadas para radioterapia, radiocirurgia e braquiterapia.
Nós somos uma empresa focada no tratamento oncológico e neurológico, através da radiação de precisão. Já são mais de 220 máquinas instaladas na América do Sul. Nesse período, nós viemos conquistando a confiança de alguns centros de referência muito importantes na região. E nós vamos seguir, porque o nosso compromisso é levar a melhor tecnologia para todos os pacientes.
Atualmente, as soluções Elekta em oncologia e neurocirurgia são utilizadas em mais de 6.000 hospitais ao redor do mundo.
Nesse momento, na América Latina, já há 12 anos, nós sentimos que toda a equipe da Elekta possui esse espírito, o espírito de levar a todos os cantos do nosso território cuidado, atenção e respeito no tratamento de câncer para os pacientes.
Nossa missão é tornar a vida do paciente possível. Somos líderes de tecnologia de radiação de precisão para a medicina. Somos a Elekta. Bem-vindo ao nosso mundo.